This video is going to be about solving equations with variables on both sides. So we're going to now take a look at the rules with solving an equation with variables on both sides. So to solve an equation with variables on both sides, you must collect the variable terms on one side and the constant terms on the other side. Constant is going to stand for the numbers, so you want to collect variables on one side, numbers on the other. So for example, we have 15 minus 2x equals negative 7x. So we want to get the variables on one side, the numbers on the other. Well, if you notice, negative 2x and negative 7x are like terms. So what we want to do is we have one of the constants here, which is a number, and we want to move the term with the variable to the other side. So we have the terms with the variables on one side and then constant on the other. So to do that, we have to use the inverse operation, which so we have negative 2x, so we're going to add 2x on both sides. So we're going to drop this down. So we have 15 equals, so we have negative 7x plus 2x, which is going to give us negative 5x. We have to isolate the variable, so we want to get x by itself. So we're going to divide both sides by negative 5 because negative 5 times x is over here. So to get rid of that is dividing by negative 5. So we're going to be left with x equals negative 3. Now we want to check every time to make sure we're correct. So we have 15 minus 2. We're going to multiply by that negative 3. So we're going to substitute that in. It's going to equal negative 7. We're going to multiply that negative 3 in to see if we are correct. So we have 15. We have a negative 2 times negative 3, which is going to be a plus 6, which equals negative 7 times negative 3, which is a positive 21. So 15 plus 6 is 21. So it's equal to 21. So we are correct. Now, another type of an example you might see with variables on both sides is you notice that we have a variable and a number or constant equal to a variable and a constant. So we're going to move the variables to one side and the constants to the other. So I always kind of like to put whichever direction you want to go. I like to always put the variables on the left side, but it doesn't really matter. But I'm going to start with the variables. So I'm going to subtract. So this is a positive 1n and a positive 3n. So to get this to the other side, we have to subtract 3n on both sides. So we're left with 1 minus 3, which is going to give me a negative 2n, minus 4, which is equal to 6. Now I want to get the variable by itself, so I'm going to add 4, because I want to also get the constants on one side. So I have negative 2n is equal to 10. I'm going to divide by negative 2 on both sides because it's the inverse operation of multiplication. So I'm left with n equals negative 5. Now to check, we want to make sure we add in those numbers. So I have n, which is negative 5, minus 4, which is equal to 3 times a negative 5, plus 6. So I have negative 5 minus 4, which is a negative 9, is equal to, we have negative 15 plus 6, which is going to give us a negative 9 equals negative 9. So we know we are correct. Another type of equation that you might see is another example is we still have variables on both sides, if you notice, but to get rid of the parentheses, we always want to distribute. So I'm going to give that 3 off to the b and the negative 4. Make sure that negative always goes with that 4. So we have 3 times b, which is 3b, 3 times negative 4, which is negative 12, equals 5b minus 2. Now our goal is to get the variables to one side and the constants to the other, which is the numbers. So what I'm going to do is I'm going to get the variables on the left side. So I'm going to actually subtract negative 5b to both sides. I'm left with 3 minus 5, which is negative 2b minus 12 equals negative 2. I'm going to add 12 on both sides because it's the inverse operation. I'm going to undo that subtraction. So I'm left with negative 2b equals 10. I divide by negative 2 on both sides, and I get b equals negative 5. I'm going to check because that's always the best option. So I'm going to do 3 times. So I have a negative 5 minus 4 is equal to 5 times a negative 5 minus 2. So I have negative 5 minus 4. So I have 3 times negative 9 is equal to 5 times negative 5, which is negative 25 minus 2. 3 times negative 9 is negative 27, equal to negative 25 minus 2 is negative 27. So I know I'm correct. Okay, I have 2 more examples left. These are going to be special cases, and what I mean by that is you'll see that they're going to have special answers to them. So I'm still going to solve them the same way. I want to get the variables on one side and the numbers on the other. So I'm going to multiply 3 by everything that's in parentheses using the distributive property. I have 3 times 5x, which is 15x, and I have 3 times 2, which is 6, is equal to 15x. Now, I noticed that I have a variable and a number on this side, and I have a variable on that side. So what I'm going to do is I'm going to try to move all the variables, because I already have the constants by itself, so I'm going to move the variables over. So I'm going to subtract 15x on both sides. Now, if I bring this down, I have 6, and 15x minus 15x is actually going to give us 0. Can you have 6 equals 0? Is that true? It is not true. So this means if you ever get an answer like this, that the answer is not true, it would be a no solution. So the answer has to be, because it is not true, 6 does not equal 0, so it is no solution. So your final answer would be no solution. So nothing will work for this equation. So nothing that you substitute in will work for this equation. Okay, our last one, you're going to solve it the same way. So we have negative 2 times 4y, negative 2 times 1. So I have negative 8y minus 2, because negative 2 times 1 equals negative 8y minus 2. Okay, you might have noticed that these now have the same exact side. So we're going to try solving this. So we have negative 8y minus 2 is equal to negative 8y minus 2. Interesting. So now I'm going to try to I'm going to put the variables on one side, the constants on the other. So I'm going to add 8y to both sides. Okay, and I'm going to get negative 2 is equal to negative 2. Is negative 2 equal to negative 2? Yes, it is. So it is true. So that means that you are going to have infinitely many solutions. So infinitely many solutions means that any number that you substitute into this equation will always make this equation equal. So these are 2 special cases that you'll see. Okay, one means no solution, means that your answer does not equal something. So 6 equals 0, that is not true, so it would always be no solution. Now if something does equal, so negative 2 does equal negative 2, so that would be an infinitely many solutions.